Okay, so it's 1 o'clock. I think we can begin the webinar. Good afternoon, everybody, to this module 1 of the Modern Road Ecologist Toolbox. And we would like to begin with some opening remarks from Mr. Qingfeng Zhang. Mr. Zhang is the Chief of the Rural Development and Food Security Thematic Group, which we also say Agriculture Thematic Group in ADB. And he's also concurrently the OIC Chief of the Environment Thematic Group in ADB. As the Chief of the Agriculture Thematic Group, Mr. Zhang is leading and overseeing ADB's overall rural development, natural resources, food security, and agriculture operations by providing relevant and practical technical advice. During his last over 16 years with ADB, Mr. Zhang processed and administered loans and technical assistance projects in green agricultural value chain, efficient use of natural resources, climate resilient agriculture, renewable, rural renewable biomass energy, healthy agriculture ecosystems, food safety, and internet plus agriculture. He has published over dozens of knowledge products and blogs on agriculture, natural resources, and environment. Prior to joining ADB, he was the director at the State Environment Protection Administration in Beijing and a senior environment specialist at the World Bank in Washington, DC. So over to you, Qingfeng, to deliver the opening remarks.
Yes, thank you so much, Kama. Welcome, everyone. Good afternoon, ladies and gentlemen. Very warm welcome. Attending this very important training on the modern road ecologist toolbox. Today, we are kicking off this training with module 1. As Kama just said, is an initial assessment of the biodiversity study design and also the data needs. To help set up the context of this training, I would like to briefly talk about the Asia's rich biodiversity and also its interactions with the transport infrastructure. As one of the colleagues here probably know that Asia Pacific region is the exceptional rich in biodiversity. The tropical forests of the Southeast Asia, the reefs of the Coral Triangle, the temperate forests, and the large river basins found in the Asia Pacific are among the most unique on Earth. And also over 2,000 of 50,000 global key biodiversity areas are designated by the International UN Union for Conservation of the Nature, this IUCN in Asia as well. But biodiversity in the Asia Pacific region is a fast decline. Roads, railways, bridges are known to be one of the major causes of the habitat loss and the degradation. They have caused direct impacts on wildlife through the vehicle-wildlife collision and also introduction of the invasive species and the indirect impacts such as poaching, pollution, and the illegal settlements as well. As you know, this year, the COP15 also going to take place in this region, in Kunming along the Yangtze River. The post-2020 framework for biodiversity conservation is a proposal to set up a goal of the not only halting, but also reversing the loss of the biodiversity by 2030. For this purpose, we need to change the narrative from the transport and the cost of the nature to transport for nature. I'm very happy to say that we have gained a significant new knowledge and several decades of the experience and lessons on the biodiversity impacts brought by the transport infrastructure. In addition, technology and access to information has significantly advanced in the past few years. So today we have access to several digital tools and resources, as you will learn from the webinar today. This brings huge opportunities for better planning and designing ecologically friendly transport infrastructure. Looking forward, we need to transfer the knowledge gained, share lessons learned, and equip the practitioners, such as the road and the railway engineers, transport planners, and the transport ecologists, and others. The information, tools, and resources today I discuss will enable our colleagues and the participants plan and design ecological friendly infrastructure in the future. Today's webinar is one of the several initiatives IDB is taken to fulfill this need. I encourage everyone to actively participate in this training today and also take a full advantage of the vast knowledge and experiences that resources person bring with us. I wish the organizers, resource persons, and the participants a successful webinar series, and I look forward to many more similar training program in the future. Over to you, Kava.
Thank you, Qingfeng, for those opening remarks and the message that we can change the narrative from transport at the cost of nature to transport for nature. So that sets a very positive tone to this overall training program. Now, I would like to introduce our two main resource persons for this training. We have Dr. Anthony Clavinger, we can call him Tony. He is currently the Senior Research Scientist at the Western Transportation Institute in Montana State University in the US. Over the past 25 years, his research has focused on developing science-based solutions for conservation of landscapes and animal populations in areas experiencing expanding road systems. He was a member of the US National Academy of Sciences Committee on Effects of Highways on Natural Communities and Ecosystems. He has published his research findings in over 80 articles in leading international scientific journals and co-authored 3 books, including the seminal work Road Ecology, Science and Solutions, and Safe Passageways, Highways, Wildlife and Habitat Connectivity. He has served as the principal investigator, planning, designing, and evaluating the use of wildlife fencing and crossing structures in projects in Canada, the US, and throughout the world. Our second resource person for today is Benjamin Dorsey. We can call him Ben. Ben is an environmental scientist, a spatial data specialist at the Parks Canada, and he works for Parks Canada as an ecosystem geomatics technician, working on mountain goat and caribou projects. He has studied the impacts of railways and roads on wildlife for the past 14 years. His career has focused on developing solutions to ecosystem and transportation challenges by applying geographic information technologies, basically GIS. And he has worked with the China Academy of Transportation Sciences and in a number of other countries around the world. So a very warm welcome to our 2 resource persons, Tony and Ben. And we will begin the training with Tony. He will give us an introductory presentation on the designing and understanding the design and data needs for carrying out a baseline biodiversity assessment. So over to you, Tony.
Okay, thank you very much, Karma. Let's see, share. Okay, can everybody see that?
Yes.
Okay, perfect. All right. Let me get rid of that. All right. I want to thank everybody for attending this webinar and the first module on web tools in the modern road ecologist toolbox. We hope that many of you will learn new ways to conduct field work, to carry out data collection for biodiversity baseline assessments, and help streamline in data collection, the storage of data, summarizing all this data, and provide beautiful and compelling displays of all this fantastic information that we collect in these assessments of road impacts on wildlife populations and biodiversity. We're most excited how these tools can be used to share information with project managers and especially stakeholders to help design the most ecologically sustainable wildlife-friendly highways in Asia, and preserve the rich biodiversity that we see today is becoming increasingly threatened and disappearing. So in this 3-hour webinar, we'll have lots of time for discussion and question and answer. The first module consists of 2 parts. I'll begin by describing the Biodiversity Baseline Assessments, or BBAs, and basic research to determine how species are impacted by transportation infrastructure projects, and the types of data that are needed to be collected to inform recommendations for mitigation. And then Ben will provide the second part where he will discuss some of these web tools, how they're used, and how to make these projects run more efficiently. Let's see. So we all know that we're in this era of the Anthropocene, where humans and human activity dominate everything. I'm actually sitting in the Canadian Rocky Mountains, where it's about 38 degrees. We're having record heat levels here, so the impact of our activity certainly on climate change is felt very close to home here. But biodiversity in this era is declining at unprecedented rates, but it can turn around, as you see in this graph here. There are ways that we can start turning these things around. But the causes for these declines in biodiversity are the loss of habitat, fragmentation of habitats, and fragmentation of these wildlife populations that depend on these important landscapes for their survival. And habitat loss and fragmentation can be naturally caused by wind events such as hurricanes, tornadoes, fires that run through areas, drought, and also insect outbreaks. But the most common, of course, is that caused by ourselves, by humans, by transforming intact natural habitats into agriculture, built areas, cities, villages, settlements, and of course, what we'll be talking about a lot during this webinar, which is linear transportation infrastructure. We do live on a paved planet. Transportation infrastructure, roads, rails, and canals are one of the leading causes of habitat fragmentation on the planet. In the last 20 years, there's been 12 million kilometers of roads that have been built, and double that amount, 25 million kilometers, are expected to be built in the next 20 to 25 years. And about 90% of these transportation projects are going to be in developing economies, not just Asia, but also Africa and Latin America, where we find the highest areas, the most rich areas of biodiversity on the planet. So there are many impacts of roads on wildlife populations, and we know the direct effects, seeing road-killed animals on the side of the road. The fact that the road is built is a cause for a loss of habitat. And we also have these edge effects, this hard edge between natural habitats and the actual road corridor. But there are many indirect effects also, as you can see here in this slide. The ecological effects of roads is quite broad, involving invasive plants, contaminants, how roads affect hydrology, subsurface flows. But in this webinar, we're going to focus on how roads impact the conservation of biodiversity and wildlife populations. And in the opening statement that we just heard, this is particularly important in Asia. Asia is a global biodiversity hotspot. Roughly 1/4 of the world's biodiversity hotspots are found in Asia. And one of these, the Indo-Himalayan region, is going to be the focus of the webinar module. So baseline biodiversity assessments. This is the content of what I'll be talking about in the next 25 to 30 minutes. Basically, what sort of information do we need to have? What are the objectives of these assessments? How do we collect the data? What are the different methods that are used to obtain the information needed to inform recommendations? Once we have all this data, how do we start forming outputs? how do we start determining where mitigation needs to be placed and how important different mitigation is in these different locations. I'll discuss briefly 2 case studies of BBAs in action, one in Bhutan, another one from Bangladesh. And last, talk about some of the challenges of managing, describing, and sharing all of this data. It's quite a challenge. And so to begin with, habitat is critical. It's critical for animal survival. It's a place where all species biological needs are met, finding food, cover, finding mates. As habitats become, and the populations that live there become fragmented, this becomes increasingly difficult for them to survive. The populations start disappearing locally. In a species range, if more and more of these local populations start disappearing, it's more difficult to maintain these important connections between them, and eventually these populations basically disappear. And roads are a cause of how habitats become fragmented, particularly through 2 main impacts. That is barrier effects. That is, there's so much disturbance or there's so much traffic on a road that animals approach the road. They may try to cross, but the chances of them surviving is very low, if any at all. And the second is wildlife mortality. Everybody has seen this on roads. Animals become what we call roadkill, or casualties on the road. And really mortality is also barrier effects, because these animals don't cross the road and the populations on both sides of the road still remain separated. The big difference is that mortality has a big demographic effect, because not only do we have barrier effects, but we also have one less individual in that population. So this is how habitats are generally arranged. Excuse me, there's some linear infrastructure outside my window. This is how most habitats are arranged out in the landscapes we find today. They're basically set up in what we call metapopulations. They're separated, but we need to be able to have animals disperse through these corridors, some form of travel habitat to maintain these populations over the long term. And these corridors can be natural or they can be man-made, but these are essential for providing these vital connections. And we do that by these man-made structures. When we're talking about roadways and railways, these consist of very site-specific passages or corridors for animal travel. And this ensures that populations are connected. So this could be overpasses, tunnels are also excellent mitigation measures to maintain connectivity, underpasses, big flyovers, and generally fencing is used, some form of fencing, to guide animals to these structures. And so many of you, I'm sure, are familiar with the mitigation hierarchy. Before projects begin, the first step is, can we avoid these important core habitats? Go around them, that is to say. If we can't avoid them, then we try to minimize or mitigate those impacts using things such as wildlife crossing structures, some sort of mitigation measures. And if we can't mitigate, then we compensate. And that is where we take this habitat or this area of habitat in the project area that's impacted, and we recreate it or restore it off-site. And so there's also, what I wanted to also mention is that there are these really red flag projects, and those are the ones that even avoidance will have an impact on areas of unique and rich biodiversity, like we find in Asia. These really biodiverse treasures, they can't be tarnished or harmed. There was a recent article in Nature that explains this need for including this option. Really don't do anything at all, or don't build in the mitigation hierarchy. And we know that it's more than just biodiversity, but also social and economic factors, cost benefit analyses that factor into these decisions of where to build and how to build and whether we should even build at all. So environmental impact assessments, stepping back a bit from BBAs, these are generally sort of course level studies using information that's readily available in a relatively short period of time. They address physical, ecological, social, and cultural resources. However, for category A projects, where the impacts are going to have the greatest harm on biodiversity, there's a need for greater scrutiny and detail. And these also require the involvement of subject matter experts, such as transportation ecologists, in these projects, who understand these issues, who work in this area, who understand the current practices and some of the solutions. So first, we need to know what these impacts are to the wildlife populations. And we know that the main impacts are mortality and movement, these two main impacts. But we also need to think about, at the beginning of these projects, what are the tax of interest? How do we define biodiversity? Are we going to focus on one focal species, such as tigers, or an entire ecosystem, or some indicators of the ecosystem? So for our project in Nepal, on the what we call the NHP project, Narangat Hetauda to Pathlaya, we've decided to use 3 different categories of indicators: the large iconic species of conservation concern, such as the one you see on the pavement there that had been roadkill. Second, canopy dwelling species, such as primates. And third, small, medium-sized terrestrial vertebrates. So the methods that we use, many of you are probably familiar with. These are examples from recent and ongoing BBAs. The type of data needs to be collected consists of roadkill surveys, as we see on the left. We look for information on species occurrence by using camera surveys and also sign surveys. And also the fact that there are so many bridges and culverts on existing highways, and if these highways are going to be expanded, we could at least collect some information on what species are using these existing structures, what species might be in the area. And that will give us some information on how we might retrofit these structures when the actual road expansion project takes place. Other methods also include forest inventories, such as this photograph on the left from Bangladesh, and also bird surveys. So primates are highly endangered globally, and they're often excluded from the BBAs. They're highly impacted by transportation infrastructure projects, as you might imagine, with the wide road corridors or highway corridors, and these areas typically, when they're 2-lane roads with lower traffic volumes, the canopies are often connected across the roads, and all of a sudden we have 70 or maybe 100 meters where there's no connection at all. So these are important species to be studying, and we study those species using camera traps and also using visual and acoustic surveys. And small, medium-sized vertebrates, they're also important to survey. Many, we find IUCN listed species in some of these study areas. We need to know what habitats are important for them, where they occur, and how to minimize those impacts. For medium-sized terrestrial vertebrates, as well as the canopy dwelling species, the mitigation measures are actually relatively low cost and easy to construct, using canopy crossings and putting in small culverts or putting in habitat elements, stumps and rocks and shrubs inside the edges of underpasses for some of these animals, which allow them to travel back and forth. So we know what we want to collect, but how do we collect it? This is just a sample of, I think, what has been used in history, and some of it is still even being used today, starting out with notebooks, paper and pencil in the field. Voice recorders have been used with cassettes. And then some of you remember might remember the PDAs, the personal data assistants, these small sort of BlackBerry looking handheld iPacs that also very much similar to an iPad, small iPad today. Those were used, and now we can use, because everybody has these cell phones, and there's so many apps, and it's relatively simple to build these apps, as we'll see in this webinar, that these are really really effective tools to have in the field to help collect data. And there's nothing wrong with some of these other methods that we use, but I hope by the end of the webinar you'll be convinced that these new tools are better. They save time and they're much more efficient. Camera traps are being used globally, worldwide, variety of different research projects in the BBAs that were conducted in Bhutan and also Bangladesh, and the ones in Nepal. Important tools to collect information on where species occur. 100,000 or hundreds of thousands of photographs are obtained from these cameras over a course of months or years. They need to be reviewed, all these photographs, this raw data, and classified to species. There's many different types of software that are available. We use this time-lapse software, which we'll hear about later on in the webinar. And this all has to be done by people. I mean, this isn't automated, and to some extent, they are starting to use AI for speeding up some of the classification, but for the large part, it's done by people. And this is usually team members, or we have volunteers or trained citizen scientists that help on this. And this is the type of output. You know, the type of data that's collected, it ends up in a huge spreadsheet with volumes and volumes of valuable data. And we need to crunch these data. So are the outputs of this field data collection from the roadkill surveys, these hotspots and clusters? We know where species occur, first of all, because they're ending up dead on the highway. We know the locations of where these animals are being killed, which is important. And then with a lot of systematic roadkill data collection, a lot of data, we start seeing patterns of where these certain species or groups of species are being killed and the severity of those impacts. So that can help us in when we start determining types of mitigation to recommend in those locations. Species occurrence from camera and science surveys also give us this species, where species occur. With a lot of camera traps, we can determine distributions of species over large landscapes. If these camera traps are separated by a highway, then it can tell us where important corridors are, because we detect the same species on both sides of the highway, and we can look at the intactness of the habitat in those areas. And then with a lot of data, we can also start modeling connectivity, and we'll hear about that by Clara Grillo in the third module. And this is essentially, these are models that use empirical data, field data, to determine the most likely path of travel throughout the landscape and across roads. And so stepping back a bit, this shows us this is just an example of project data from our project in Nepal. On the right-hand side, we see 4 different methods of monitoring: underpass monitoring, science surveys, bird surveys, roadkill surveys, and of course, camera trapping. And we can see the flow here. This is what leads into the connectivity model. And in that connectivity model, we can also use these methods or the data collected on the right to validate those models. And we were very fortunate in Nepal on this project that we were able to utilize the NTNC data from the National Tiger Survey in 2018, 2.5 by 2.5 square kilometer cells, each cell with a camera trap, and these were run for several months, and a lot of data was collected, and we're able to use that in our project. So it helps to look around and to search around and see what other projects have taken place and tap into some of that information for baseline biodiversity assessments. And so finally, we get to this situation where we have all this data. It's been starting to be analyzed. We have some locations based on roadkill, based on species occurrence or camera traps. And they're basically locations on the highway like we see here. But we know that all of these locations aren't equal in terms of conservation value. And therefore, there's a need to be able to prioritize these sites in terms of their importance for mitigation. And we do that, we've done that in several different ways. We use different criteria, which I can talk about later if anybody's interested, but it's basically the criteria is based on roadkill data. If we have that roadkill data information, the importance of local and also regional connectivity for that species, the intactness of the habitat, how that habitat connects to larger core habitat areas, larger landscapes, for example, protected areas, and even the constructability we often use as a factor. How easy or how difficult is it to construct mitigation in these locations? And we typically have 4 or 5 different criteria, and we score these from 1 to 5, and we essentially end up with these sites that are extremely important, these primary sites, and then these secondary and tertiary sites. And we know that these primary sites are the ones that are going to receive the highest dollar investment in terms of mitigation. And this is sort of I always see it as sort of a strategic way of working with transportation ministries, because we can't invest the same amount of money in every single location, and we don't need to. But there are certain locations where we need to invest a lot of money in proper mitigation. And if we can't do that, then the project is going to suffer and it's not going to meet the safeguards goal. So this prioritization is a way of being able to determine where the most important areas are to mitigate. And so that's one way, and that's typically done with the large iconic species or the focal species in a project. But then we layer this other information. So we have this first layer, which is primary, secondary, tertiary locations for these large iconic species, but we also want to know, how does that match up? How does that overlap with the canopy dwelling data and also small and medium-sized terrestrial vertebrates? So today, right now, I'll just briefly describe 2 of these projects that have been done, ADB projects in the last 5 years, using a baseline biodiversity assessment. The first one is a road project in Bhutan, and the second one is a railway project. In Bhutan, this was a part of the Bhutan's Road Network Project 2, the National Highway 2 and National Highway 5, and also the proposed road that was going to traverse the Phipso Wildlife Sanctuary. And just to give you some background, Bhutan, much like Nepal, highly mountainous, extreme elevation gradients from lowland to high alpine areas, high biodiversity. More than half of the areas is protected in protected areas, and this Road Network Project 2 consists of the East-West Highway. However, this southern portion of the East-West Highway is where NH2 and NH5 is found, and also this proposed road through the Phipso Wildlife Sanctuary. This shows you NH2. These are along the border with India. You can see NH5 to the east, NH2 to the west, and the Phipso Wildlife Sanctuary is somewhere between the two. It's a little bit closer to NH2 than it is NH5. There was an EIA conducted on NH2 and NH5. These were areas where conservation of connectivity of the Asian elephant population was a concern. Wildlife crossings were recommended. These have been built and they're actually being monitored right now. The Phipso Wildlife Sanctuary work and the BBA for that project began in 2014. This was the first BBA in Bhutan. And this was, again, it was on the Indian border. They surveyed 4 different zones based on terrain, elevation differences, and also the vegetation differences. So starting with the border lowlands, the lower foothills, mid foothills, and then the upper foothills. And they started out with a desktop screening, looking at important areas for biodiversity, looking at the screening, the species list of IUCN to see what species were in this area. They conducted camera trapping, forest vegetation inventories, and also bird surveys. They had 33 camera sites. They monitored these cameras for 6 months. In addition to, previous to that, there was about 4 months of wildlife camera trap monitoring that was done by the conservation officers in the wildlife sanctuary. So this was added to their database. More than 4,000 mammal images, 27 species, 15 species that IUCN listed, and 2 of those that were critically endangered. And some of the lessons learned on this project is that these 2 segments, there were 2 segments that were going to pass through critical habitat, the upper and the central, the northern and the central alignment. These weren't compliant with ADB. So they have recommended that the proposed road pass through the lower areas of biodiversity on the core, on the border, excuse me. And this realignment was recommended after this baseline biodiversity assessment was completed. This resulted in avoidance and no net loss of biodiversity. This included input from national and international specialists, as well as staff at the wildlife sanctuary. In the end, this road construction was canceled due to the fact that there was security and safety issues along the Indian border. So, and the second one is, the case study is in Bangladesh. This is a railway from Chittagong to Cox's Bazar, the railway. This railway passes through 3 different protected areas: the Chinati Wildlife Sanctuary, Fauzia Kali Wildlife Sanctuary, and the Mendakachapia National Park. These are 3 protected areas where Asian elephants are present. It's a Category A project, the reason for the BBA, of course. And this baseline biodiversity assessment was conducted in all 3 of these protected areas using camera traps, sign surveys, bird surveys, and also forest inventory of forest vegetation. In the end, there were, in the first wildlife sanctuary, 2 wildlife overpasses were recommended after the BBA was completed. One of these wildlife overpasses has been completed. The second wildlife sanctuary, fencing at wildlife crossings near the crops was implemented. That was the main recommendation. And then in the national park, fencing and detection systems at the ends. What's important to note is that these are data-informed recommendations based on the results of the BBA. And what's interesting in this project is that there was really a diverse strategy in each of these different protected areas. There were different issues to resolve. The maintenance of corridors. In another one, it was reducing collisions on the railway. And the third was minimizing human-elephant conflicts. So the lessons learned from this project is that it's a very complex project in all 3 of these different protected areas. A full year of data collection was required. This included data collection not only during the wet season, but also the dry season. So getting these seasonal differences and the importance of local, national, and international experts being involved in these projects to help collect data to inform decision-making on the different mitigation recommendations. So you can see for BBAs or intensive pre-construction field studies that these are very complex. A lot of moving parts, a lot of things going on, a lot of different types of data collected. And the data needs to be stored digitally and not on paper. We need quality control checks of the data. Eventually, these data need to be summarized. They need to be displayed with map interfaces and also shared. in the past on these type of projects, we might have one hard drive for storing this data. Typically, this might be the team leader, or it's going to be stored on the hard drive at the office. And we're using sort of an assortment, isolated assortment of different software, from Excel to camera trap software, maybe some statistical software, QGIS, and we may have a website for this as well. These are all sort of dispersed and not linked in an efficient way. So today, with these modern tools and open source data, we can interface all of this and probably more. And maybe that's an advanced topic for that we can see that might come out of this webinar. We have one data platform. We have analytical tools. We have high resolution spatial data. We can add data to these displays in real time as they're being collected, as roadkills are being collected. We can add up, this data can be uploaded and mapped almost instantaneously. And most important, this data can be shared with team members, with government agencies, with lending institutions, NGOs, engineering consulting firms, and on and on. So these are really remarkable tools and really remarkable digital infrastructure that's low cost or free, that can make the life of a researcher or somebody conducting a BBA much easier, and helping to streamline data analysis and project deliverables, sharing data with stakeholders as the data are being produced. And they provide data-informed maps of species occurrence, potential impacts of linear infrastructure, and compelling evidence for biodiversity safeguards and their conservation value. Thank you very much.
Thank you, Tony. Before we move over to Ben, I was wondering if you could take a couple of questions. We already got some interesting questions from the audience, from Izzatullah. So it's a very important question. The first question is, how can we conduct cost-benefit analysis for road passing structures specifically for animals? It's a big question, but yeah.
It's a good question. I'm not an economist. I mean, I think, well, at a larger scale, if you're talking about the impact of an infrastructure project, those cost-benefit analyses are done quite readily, and we've seen those with the Conservation Strategy Fund, and others do those. Typically, cost-benefit analyses with regards to mitigation measures for wildlife have been done in terms of the reductions in property damage, the reductions in cost to society. And this has been done in North America, and it's actually been done quite successful, and it's actually gotten many transportation agencies to listen and to understand, because the bottom line for transportation agencies is the dollar, is what these costs are and what they cost to society. In developing economies, that may not hold, that may not be as strong, that relationship. But the idea is that with collisions with tapir, with elephants, with large mammals, we not only have property damage to those vehicles, but we have human injuries, and those you can put a dollar figure on those. And we know that, for example, in North America, that the average deer vehicle collision costs $6,000. The collision with elk, which is slightly larger, is about $17,000. And for moose, it's about $30,000. And that's based on property damage, based on what it costs for human injury and even human fatality, the cost to society. And so we know what these mitigation measures cost. We know what an underpass costs. And we know what that threshold is on a highway. And I would be glad to share this paper that was done by a colleague of mine at Montana State University. And we know that it's about 3.4, if the average of 3.4 deer vehicle collisions per kilometer per year on a section of highway, it makes economic sense to mitigate that stretch of highway. And that's taking into account the lifespan of that mitigation, which is I forgot what it is in that study, but it's something like 70 or 80 years, because that's what bridges, that's their lifespan. So there's ways of determining the cost benefit based on cost to society. The problem is this is typically, well, I guess, yeah, we don't know what it costs to conserve tigers. We don't know what that economic cost is to conserve one-horned rhinoceros or elephants. But if we knew that, we could get at some much more detailed cost benefit analyses of how these wildlife crossing structures benefit society and the economies, the local economies. I hope that made sense.
Yes, it did very much make sense. Thank you, Tony. And I think in addition to what you mentioned, we also have the value that these road crossing structures contribute to maintaining connectivity for wildlife and having the wildlife there, particularly in countries such as Nepal, where there is a lot of tourism, and ecotourism is an important source of income. So you also have that sort of income which could be lost if you don't have these kind of structures, and particularly with people who are, certain roads or projects, they get a reputation if they are known to be having a lot of wildlife collisions. So then there is like the negative publicity and people probably not wanting to visit the site as a tourist. So there is this also negative impact of that. I see a couple of other questions, many questions, and I think Ben is helping to answer some of them.
Okay.
And there is a question from Fugfam: is consultation with local communities useful for BBA?
Very much so. I didn't mention it in ours, but we, not just only our project, but in many projects, the value of local knowledge is very important. And we wanted to collect that information as part of the roadkill surveys, to stop in at the settlements in these habitats, these intact habitats that cross the road, just to get information from the people that are living there, in the little in those areas, to find out what species have been killed, what species have been seen around the highway. It's just additional information, but this information is also very important to have as well, to be collected with, in addition to roadkills and species occurrence data.
Mm-hmm. Yes, absolutely. Thank you, Tony. So just one last question, and then we can move on to Ben's presentation. So, and this, I think I recognize the names. They are from our Bangladesh projects. So I'll combine the two questions on how to assess biodiversity, I guess the effectiveness of the mitigation measures after the construction of the overpass and the underpass is completed. So how to assess the effectiveness of that. And I think you touched upon this already in your presentation, a question specifically for mitigation measure for arboreal mammals like primates. So yes, it's kind of two questions bundled into one, but I coming from the same project.
No, there's many different ways to assess what we call the performance of these mitigation measures, or the wildlife crossing structures. And it can be very simple. The most simplest and the most cost effective, and is basically monitoring what species are using the structure. But even though they're using the structure, doesn't mean that, that individuals or that there's actually gene flow occurring, that animals are using these structures to find mates, to reproduce, and that also that young are able to disperse out of these areas and connect. So there's really sort of a scale of measures, performance measures, but the simplest is basically, are these focal species using these structures? Are they males? Are they females? Are breeding females using these with young? These are the type of ecological interactions that we want to have happening at these structures. You can get into more complex measures, such as are predator-prey interactions being restored? Are animals able to recolonize areas after local extinctions, or or fire events and things like that. But typically monitoring passage use and also looking at the next level up would really be looking at things like gene flow. Are these structures helping the population on both sides reconnect, and is the genetic variability increasing because of these structures? And those typically are more longer cost or longer term, and also more cost intensive. With regard to the canopy crossing structures, there are many of these that are being built. There was several that were constructed in Chitwan National Park just last week. We saw an article in the newspaper. They're being built throughout Asia, throughout Latin America, and wherever there are primates, there's a growing trend for these arboreal, these canopy crossings to be built. They get to be more complex when that gap between forest becomes quite large, like 70 or 100 meters. If it's 50 meters or maybe less, it's they're more readily used. But once they get larger, the animals are crossing in much more exposed habitat, and a little bit more difficult to have these things be more effective in these wide highways or these wide transportation corridors.
Mm-hmm.
Yeah.
Right. Thank you for answering those questions, Tony. And just to our audience, please keep putting in your questions, because we have allocated another 30 minutes of Q&A later. So I think we should now move on to Ben's presentation. Ben, can I invite you to take over?
Yes, hello everyone. Thank you all for the opportunity to present and share with you some of the things I've learned while supporting Tony for the last 15 years. Tony, we've been working on these projects. In one of your slides, Tony, you show some of our old tools. And in truth, one of the first tools I got while working for Tony was a rake. Before the advent of motion-activated cameras, we used track pads on wildlife overpasses to record species crossing over the Trans-Canada Highway. So things have progressed significantly since then. So it's a pleasure to present to you tonight. I'm going to cover a few topics here first, and then we're going to move into demoing and using some GIS tools to give you some real experience and see the ease of using these things. They are truly a tool similar to a rake. They as a practitioner, I'm trying to get my work done as efficiently as possible, and these tools allow me to get my work done and share and communicate with a team all around the world. So we're going to quickly go into what is GIS and why is it so important, just to make sure we're all on the same page. We're going to cover some software models, discuss software as a service versus free and open source software and its trade-offs. We're going to talk about why use WebGIS for BBAs. Then I'm going to cover the types of GIS data that we use and some data considerations. These two last points before the demo, if you're going to take notes or take something away from this presentation, those might be the two sections where some insiders info from doing this work for a number of years. Okay, so what is GIS? GIS is Geographic Information Systems. We've all used GIS, we have a small type of GIS on our phones, most of us, whether that's Google Maps or maps on an iPhone. Fundamentally, what makes a GIS function is the co-alignment or registration of spatial data in such a way that they are interactive. We can turn them on and off, but more importantly, we can analyze them in the context of each other. That analysis can be qualitative or quantitative. So just looking at a map, sometimes you can identify the fastest route to the nearest store, but we can also analyze that quantitatively and calculate the speed and distance to the nearest store, and include things like dynamic data. You know, we're all using these tools here locally. Maybe that's traffic. Maybe there's some road construction and we need to drive a different way to get to the coffee shop. The key thing about what makes a GIS a tool is that it adds meaning and context to our data. It gives us a common understanding and a picture that transcends a static map. By being able to zoom in and out, we can understand not only the dynamics of maybe the effects of placing a highway in a certain location, we can also understand the context of that location within a larger region or country. This next slide is a deep dive right into what is WebGIS. Across the bottom, you'll see we're talking about the foundations of a WebGIS, the data and web services. Somewhere for all of these tools, there's a computer plugged into the internet that holds a database. With software as a service, this entire stack is built and maintained for us when we subscribe to an account on ArcGIS Online, for example. In the middle, the portal, that is the thing that has really evolved over the last 5 to 10 years and takes this technology into a practitioner's hands and makes it truly a useful tool. The portal is the level at which the data in the database is exposed to the end user, including things like password, permissions, sharing, speed of access and types of access, and as well as an interface to search and find, to understand when was the data published, who was it published by, and is it complete? Across the top are the ways we consume WebGIS. We can consume them in a desktop program like QGIS or ArcGIS Pro, 2 different software applications that can consume both proprietary data feeds, like what we're going to demo today, but also open source tools, even those supplied by SPADE, the ADB's data warehouse system. Obviously, the other 2 ways we can consume WebGIS resources is through a browser and through a mobile device. The mobile device is the tool that in our team for BBAs, that really translates the work we do to the technician to on the ground. So we do 2 things with WebGIS on the ground. One, we collect new data. We use a tool, Survey123. It's a smart form system. It allows contextual data input. For example, in a road construction project, if we're conducting a species survey and we come across a dead animal, once we type in some of the information and we say the animal is dead, we may get asked different questions than if the animal was alive. The WebGIS in this slide, the desktop web and device, also helps us understand that it can be consumed by different members of our teams who have different needs and uses for the data. In the second webinar, we'll show you how to build dashboards and apps and publish your own data. The dashboards and apps are a tool we use to present data to our team leaders. You know, I build dashboards and apps to share with Karma and Tony. You know, how's our project going? What data are we using? How much field data have we collected this year? So WebGIS is a communication tool, like Tony was describing. Before I move on, I'll just discuss a few pros and cons of software as a service and free and open source software. The software as a service we're going to demo throughout this webinar series, ArcGIS Online. In Canadian dollars, a subscription costs about $800 a year. And that's a significant cost. I've worked on projects in Tanzania and other countries where I worried after the fact, after training and working on a contract with nationals, that they may never use the software again. And so that was a real concern. Versus software as a service, versus free and open source software, the free is in the name, right? So the cost of free and open source software, however, is in the added time it takes to deliver products, to build tools, and the requirements generally for a somewhat higher technical skill level. In my experience, to get my job done, I tend to go to software as a service. Although for the project we're going to demo next week, we did build some free and open source software tools using R and R Shiny. You know, the other pro for free and open source software is I often think of it as a humanity plus, that humanity is coming together, much like this webinar, and we're sharing information freely. As I thought about it this past week, companies like Esri, I think also provide some humanity plus services. Their training, the free accounts that we're all using for this webinar, and the reduced accounts. Esri offers a reduced price point for people working on conservation projects. I'll put a link to that application for a reduced cost account in our hub website. Okay, moving on. Why is WebGIS crucial for BBAs? WebGIS provides a framework. Our work is often quite iterative. It starts with data management and integration. In a BBA, Tony and I will typically start by collecting as much data as we can. And we start with authoritative data. Typically, I start with satellite imagery. Satellite imagery provides a base map and context. We will quickly create some visualizations, create some draft maps to show what is the extent of the data and what is the quality of the data that we can compile. And rapidly, we may do some initial analysis and modeling. We may identify a sampling grid or identify transects, or where are potential locations to put things like camera traps. From that, we will plan and design, make some decisions, and start some actions, right? Plan and design field work. We may communicate our project plan to our sponsors or funders or project managers. As the project proceeds, this cycle, this framework of managing data, mapping and visualizing, making decisions and communicating it, it goes around and round multiple times. And that is one of the values of WebGIS, is because it provides this common situational awareness, which is we're all looking at the same information presented the same way. The shared situational awareness is something that the longer I work in teams, I hold in high regard. I've been challenged in the past to find an email that another person thought was very important. And that email was the top thing in their email inbox. But for me, that email was buried, and so I never read it. So logging into a dashboard or using an online web framework for data collection and management is a huge asset. Okay, moving on. So in the next couple of slides, I'm going to dive a little deeper into the data and the types of data and considerations for biodiversity baseline assessments. WebGIS and traditional GIS pulls together a large number of file formats, whether that's satellite imagery, which we commonly refer to as raster data. Raster data is the same as a picture taken with your cell phone, where each square or cell or pixel represents something. And we use a large suite of different types of raster data from various space agencies, whether that's European Space Agency or USGS with its very commonly used Landsat satellite data series. In BBAs, we often need to visualize CAD data, computer automated design data, and that's possible. CAD data is often one of the ones that creates a headache for a technician like me, but we do it all the time. In webinar number 2, we'll show you how to visualize and represent some common data sets like comma separated values, a simple table of latitudes and longitudes. Okay, so some data considerations. Here in this slide, I show you 3 different types of raster data. On the far left is a scene from some LiDAR data of a forest, right? LiDAR stands for light detection and ranging. It's highly detailed data. In the center is a photograph, an oblique photograph, in fact. And in truth, we can actually use even an oblique photograph and georeference it in a GIS. And one of the things I've done here for the national parks is digitize the extent of snow and ice from photographs. On the far right, we have a land cover data set, a global data set. And I show you these 3 different scales because in truth, when we're looking at data and our data needs, we often think we need the highest resolution possible. In fact, that's not true. And LiDAR data is a great example. LiDAR data is of large extents, say of a park, a national park, can be upwards of many terabytes in size. So the data can be very challenging to share or distribute. It can be very taxing for a computer to visualize or use that data. So my take-home point here is the resolution of information is an important decision point. Do we need 30-meter pixel satellite imagery, or do we need 1-meter pixel satellite imagery? That's all informed based on your analysis needs and your goals, and in some cases, the species that you're trying to understand or protect. This holds true for vector data too. By vector data, what I mean are the points, lines, and polygons represented in a GIS. We use lines to represent streams and roads. And similarly, a road can have several resolutions. We can represent a highway in a very coarse scale that may not be as precise as we want, but across a continent or a nation, coarse scale representation of that road may be sufficient. Some things to be aware of when we're talking about data and the resolution of our data. One of the fascinating things, and you'll actually see this in our exercise 2, where we analyze some data from the IUCN Red List. The data it stops at some political boundaries. And this is a common challenge. Countries and provinces and states will often fund data collection efforts. LiDAR data is a great example. Canada right now is collecting nationwide LiDAR data. However, as they collect it, they do it region by political area. So common challenge is we're doing a road project on a section of highway that transcends a political boundary. And so we only have the data we need, maybe for part of the project. Furthermore, along that same line, some data may not stop at a political boundary or in lesser populated areas, but the data quality may change. And that's something to be aware of and to assess. That's one of the beauties of using online data sources. Much of the data we'll use online, it's published, it's curated. It's what I typically call analysis-ready data. We know its completeness, we know when it was collected, we know what it was collected for, we'll know its resolution. It really speeds up the process of curating the information we need to do our analysis and being certain that the data are complete and proceeding with that cycle, that process that we talked about earlier. I'll just cover a few more points about data here. I'll check and make sure I've hit all my topics. One of the things I wanted to share with you when searching for data for BBAs, I'll use some slang here, and that is, I often think, start with the low-hanging fruit. I start with the most easily accessible data that's in the easiest to find, most complete, analysis-ready format. And we'll highlight that as we add data in a little bit to a map. We'll show that the ArcGIS Online portal has a system of filtering authoritative data or analysis-ready data as you search for data to add to your map. We rarely need to pay for data today. The exceptions to that are some imagery products. If you're doing a highly detailed assessment of a small area or a remote area, you may need to purchase data. That data is getting cheaper and cheaper to purchase, whether it's satellite data or imagery you can collect from a drone. If you do find yourself purchasing data or needing to manipulate data, say you don't have some low-hanging fruit, And that analogy is based on the idea of collecting an apple off a tree, right? You get the one that's easiest to reach instead of the one way at the top of the tree. If you do find yourself processing data or collecting data, from my experience, I recommend scripting that analysis in both WebGIS and the software tools, and in open source tools like R and Python. We can script our analyses so that they're reproducible and they're transparent. In many areas now, our analyses are becoming more complex and more sophisticated.
Hi, Ben. Can I interrupt briefly? Are you still on the slide on data considerations for BBA, or have you shifted?
Yes. No, I'm sorry. Yes,
okay.
I'm still there.
There was someone from the audience mentioned, and I also had that question. Maybe you had moved on to the next slide.
Okay. So we'll shift gears now, and we'll go through a little bit of a demo of some online tools. How am I doing for time, Karma?
I think we're okay.
Okay.
Since we are already, parallelly, we are also addressing a lot of the questions. We have some questions for the Q&A. So far, so good. Thank you.
Okay, so I'm showing our webinar hub here. In fact, this hub is built with the ArcGIS Online web platform. And I'll just show you a few things. If you haven't inspected it already, we do have a survey that many of you have filled out, and thank you. In fact, the survey is linked to this website, and we can see where many of you are from, because the survey uses one of the field data collection tools, Survey 123, and the blue markers here show where some of your co-attendees are from. If we look at that a little bit, this is the interface for Survey 123. We can see the responses, and this entire interface is in one of the first slides I showed. This is part of the tools that make WebGIS a very efficient and user-friendly tool today. So we can inspect these data live as they come in a back-end environment here. I can make a map of those data in ArcGIS Pro and a professional tool, or I can show them in the webinar website. So there's a live real-time connection for you for the integration of the web tools. But below that, here you can see the content library for the groups. So if you do follow the exercises and create a map, you can share it to our group and it will show up here. And below that, we'll be posting more information and links to some of the resources that we'll use in the webinar. And also some of our questions relate to work that Tony has done in the past in some of his publications. I'll just highlight that there's an extensive list of resources on Tony's website there. Okay, so moving on here, I'll show just a little bit of WebGIS and some of the tools you have access to. Really quickly, here's a live data set from some work we've done in the past year in Nepal. This is showing roadkills along a section of highway. I'm simply showing you this to highlight the fact that WebGIS isn't just 2D, it's 3D. And some of the questions we ask are better put in context when we can understand the dimensions in both X, Y, and Z, or Z, as we're supposed to say in Canada. Next, I'll show you the interface for ArcGIS Online. If you log into a free public account, you'll see something that looks like this, although with a lot less content in it. It'll be empty. And here you can see there's a suite of tools that are provided as well with a free account. There's tools across the top here for developers for programming and building custom applications. There's the Hub tool, which is how we built the webinar website. The Living Atlas, which is a data repository to look at briefly. There's tools for creating dashboards, which we'll cover next week. Survey 123, which I've mentioned a number of times, along with there's a few other field data collection tools here, both quick capture and field maps. And then there's Experience Builder and Story Maps. Both are designed for presenting and communicating information to your team. And importantly, through the sharing tools and use of groups, all of these tools can be shared from individual to individual. They can be completely password protected. They can be shared to the world. Or like one of the things I'm doing from my work is sharing between agencies, from one agency to another. So maybe we want to share data with a transportation agency, but we don't want it to be exposed to the world. So we can build groups to do that. Okay, the main functionality that helps us get an understanding of the utility of this tool is a map interface. And here you see the default map is we create a new one. I'll zoom over here and put it in context. And I'll demonstrate just really quickly some of the simplicity of curating some content and creating a web map. So here when we say add a layer, it defaults to my content. And this is data that I've either saved to my account or I've published. It may be data I've collected or links that I've bookmarked. So we can see here a study area extent I've saved for Yunnan province. But typically what we're doing, say, for example, early on in a DBA process, when we're curating lots of data, is we're pulling together authoritative and reference data. And that could be vector or raster data. So just demonstrate one of the first layers here we could add would be protected areas of the world. And you'll see some icons as these layers come up down in the bottom left of each tile for each data set that we can add. And these checkboxes are significant because they tell us that some of these data are authoritative. In truth, there'll be many layers published by other users and other accounts that may be done for a class project or part of a webinar. But we can highlight and see that the protected areas layer we would like to add to our map, it's authoritative. And what that means is the organization or agency responsible for publishing that data has put it online for us to use, is going to keep it up to date and ensure its accuracy. The other thing you'll see quickly from adding a layer like this is it comes in with some default symbology. Symbology is just how spatial data are represented on a map. And we have control of that. So we can control things like the transparency. Maybe we want to see some imagery underneath where the protected areas are. Or maybe we want to change the color of that data. Simple. So when I build a map, typically I don't, for a project, I don't actually do it in the web browser like this. I'll just stop sharing and demonstrate one last thing before I'm finished. I'll share with you my desktop application. This is ArcGIS Pro. And I'm showing here some data from another project. This is here in Canada. This is a derived product. This is the result of an overlay of about 20 different data sources to understand the conservation value across a landscape. The primary reason for me showing you the software in this map, however, is to show you that the web GIS capabilities are not just connected to a web browser. They're actually connected to this software application as well. So the data layer we just added to the web map is also available here through this application. So we can add the same world database of protected areas to our map. With that added, we can do things like geospatial analysis. We can connect this to statistical analysis algorithms, both stored in ArcGIS Pro and algorithms that are outside ArcGIS Pro. For example, by using Python programming or R. Okay, I'm going to stop sharing and return to my last slide here. Because I just want to cover what's coming next week before we move on to questions. So next week, we're going to keep going deeper into the data and how to build a web GIS and pull together the tools for conducting a VBA. We're going to discuss what to do when the data you need do not exist, how you would collect and set up surveys, camera traps, even how you would collect what I'm calling here local indigenous knowledge. So how would you gather information from local communities? And we're going to demo some tools, how to build surveys using Survey 123, and how to build a dashboard. And then the exercise we'll put up in a few days on the website. We'll give you a challenge to build your first dashboard. If you haven't done the first exercise, please do. And please share your web map with our group. Okay, thank you. And I will
Thank you, Ben.
share.
So yeah, very interesting. And we have a couple of questions. And let me read out Suva's question, Suva Lakshmi's question, which is very relevant to what you had just mentioned about the data and being authoritative. So her question is, what is usually the source of this web interface data? And what is the frequency of the data being updated? And can we add our primary ecological survey data to this interface?
Exactly. So depending on the data source, it'll be published. So we'll go into that in more detail maybe next week. As you add layers to a web map through the ArcGIS Online platform, or even just search for them. We'll post some links to both the search tools and to there's a tool I wanted to share, but I didn't. Part of the living atlas of the world, and we'll post information there, and from that you can inspect it. And most authoritative data providers will document for each data layer when it's updated, when it might be next updated, and its completeness. I'm not sure I answered all the questions there, but.
Are you able to add, can we add primary survey data to that?
Exactly. That's exactly what we're going to do next week, both in a tabular format. Say you have some data in a Google spreadsheet. And in fact, that is what we'll add, some points stored with latitude and longitude coordinates from a Google spreadsheet to a web map.
All right, thank you. So, okay, you know the IBAT tool, right? So there is a question on this. Is ArcGIS recommended as an additional tool to IBAT? The integrated biodiversity assessment screening tool that we have. So I guess it's like, what's the differences and similarities, I guess, and can we work on it together with the two tools?
Yes, I haven't used IBAT. You know, as someone outside the agency, I understand both SPADE and IBAT are internal tools. For numerous agencies I've worked for, we have similarly enterprise systems that are protected, and they make a lot of sense. As we move forward, many of these tools are using the same technologies. In fact, the folks creating SPADE work with ESRI and build tools using similar technologies. In general, because they're built using similar technologies, we can integrate them. And that was one point I meant to share, is that, in fact, almost every map I'm making today, there's data coming from different, it's even stored using different technologies, but from different agencies, from different governmental organizations, and some of my own data. So it is the combining of data from different sources. In fact, that, you know, ADB may be responsible for publishing some data, and so is NASA or USGS, and so is Ben. He's published some data. So I combine those sources to make an informative product for doing a BBA.
Right. That's what I think, because we use IBAT quite a lot in ADB. And from what I've seen in IBAT is they have the database for the protected areas, the key biodiversity areas, so all the so-called important biodiversity zones. But then it doesn't show the road alignment, for example. So what's there naturally? And I feel like that's where you overlay the IBAT information with the ArcGIS information data, and that's where you can overlay and you can see. Because usually at the moment, how we do it is we have to draw like a polygon to show where our project is located. So we have to like actually draw something, and then we have to see how that fits with the location of the biodiversity sensitive area. So I see that there is a lot of value in combining different kinds of data set from different tools, as you mentioned, Ben. And if we can take a couple of steps back and go back to some of the questions in relation to conducting a biodiversity assessment. And perhaps, Tony, can I invite you to also turn on your camera? Because I think you could also help to answer some of these questions.
Sure.
And this is another question from my colleague Suva Lakshmi. This is with regard to the main challenge when we are carrying out baseline biodiversity assessment is about defining the actual season based on which the vantage points need to be defined. Because there are seasonal changes, right, in the biodiversity and the behavior patterns of those species, of the wildlife species. So how do we define the number of exact vantage points of avifauna, especially related to small, shallow ponds and large water bodies? So I guess her question is around designing the timing, as well as how do we identify exactly where, like the location of where you do the data collection.
Yeah, I don't have a lot of experience in avifauna studies, but I would imagine that, you know, you would be certainly wanting to survey or sample during the different seasons of the year. I mean, typically wet season and dry season to start out with. And then in terms of vantage points for bird surveys, you know, you would try to have these vantage points in different types of habitat, I would think, and certainly, of course, where you're able to where visibility, of course, is going to provide the greatest amount of data in terms of sampling the bird population in those areas. I'm sorry if I can't provide any more. I haven't done many bird surveys, and perhaps there's others. Asif, I know is might still be on. He's done some of the bird surveys in Bangladesh, or other participants that may have some insight into that.
I can actually add a little bit to that,
Perhaps
answer.
you could,
Yes.
yes.
I think basically we can just do like a combination of the visual rapid survey, where, and of course birds is more likely where there are lots of trees and forests, and since it's easier to see, so I think it's good to do an initial rapid survey, and also to talk to the local community people about the presence of birds. So I think do some kind of initial rapid data collection in order to design the you know the specific details of exactly where to do your
survey afterwards.
do exactly where to do your bird survey, and it can be done, you know, either by staying in one particular location and then just doing like a 360-degree turnaround.
The point count method,
Yes.
from one location,
Yes.
That's what we did in Nepal also, and I think that's what they did in Bhutan and in Bangladesh. They were using the point count method, so they would stop in one location and then they'd survey, and then they go to another location, and those were along the same transects where they had cameras, and also were looking for sign, I believe. So that was.
And also listening to the bird calls, the sounds of
the acoustic monitoring, and that's becoming more and more common nowadays, is the acoustic monitoring, because these monitors, you know, they're sort of like the trail cameras 10 years ago. They're becoming relatively inexpensive, and you can have it configured to record at different times of the day. You don't have to be there, and the resulting sound files you can send off to, you know, here they send it to the Cornell labs, which have all the, you know, they run the sound files through through their software, and they can determine species from that. So it's probably easier than identifying hundreds and hundreds of thousands of camera trap images of wildlife.
Yes, and there are also some apps I discovered which where you can listen to different bird sounds, so you can kind of, I guess, compare, and those can be useful when you're doing your bird surveys.
Yeah, for sure. And I know that also some people send those sound files to experts, basically, who know every single bird song that's out there, or bird call. So there's a lot of different ways to have all that data analyzed.
And another question, and this is also from my colleagues, from Laureen. This is a very important question. Are there biodiversity measures that affect community livelihoods? So
I'm not sure if I understand the question. I'm not sure.
So is there any kind of
Biodiversity safeguards or
biodiversity safeguards? Yes, it could be biodiversity safeguards or biodiversity conservation activities, which can have an influence on community livelihoods, either negatively or positively.
positively? Yeah.
So if I think about it, I think we can, particularly in, again, example, Nepal, as well as other countries in South Asia, where we have a lot of afforestation activities, where we are trying to improve the biodiversity. And in fact, that's what we are doing in Bangladesh, where we engage a lot of the rural, people from the rural areas for the tree plantation activities. So that could be a source of livelihood.
Yeah.
In terms of the temporary income they earn, it could be that way, as well as other ways. I know in Bangladesh, with regard to the roadside tree plantation, where there is a cooperation between the road department and the local community, and there is a partnership where the local community agrees to plant and take care and maintain the trees, and then the trees in turn are they help to stabilize the road embankment. And
Yeah.
plus it looks nice, it has the environmental ecosystem services benefit. And then some of the trees are fruit trees, so then there is an agreement between the road department and the local community forestry groups that the community can harvest the fruits, and after a certain number of years, if it is timber, then they can also sell the timber.
Okay.
There is that kind of livelihood arrangement in some countries. Okay, moving on. So we have a couple of questions here in the chat box. So this is a very interesting question from Jose. What are proper environmental recommendations if the BBA found the overpopulation of a species which could impact other species and put risk on road users and general public? So it's kind of not really linked to
another very tough one. Proper environmental recommendations. I'm not sure if there are any out there for that specific case. But if you have, if you're basically talking about a species that might become so overpopulated that it's becoming a traffic hazard, a motorist safety issue.
Yes.
I think that's what he's talking about. Yeah.
Yes.
In some places, increasing hunting is what they've done. Whether that's as a way to reduce the population of the species, which is hyperabundant or superabundant and causing all these accidents on the highway. But other measures, I mean, typically, if these hyperabundant or overabundant species are causing these problems with motorist safety and with traffic and the road users and general public, there are some measures to reduce the likelihood of these animals getting onto the highway, even though they are relatively abundant. So things like fencing, stretches of fencing to try to prevent these animals from reaching the roadway. I'm just thinking off the top of my head some of the type of measures that might be used to restrict access to the road and prevent accidents, or somehow decrease the population size if if this population is so large that they're creating risk to motorists on the roads.
Yes. So I agree, Ben, because I think this is in relation to an issue which has like the bigger policy level, which needs a bigger policy level intervention for that particular species, which is becoming overpopulated. But within the scope of the project, the best we can do is to do this kind of wildlife fencing to prevent traffic hazard because of too many of these species crossing the road.
Yeah.
So I think there are kind of two levels, and the level that we could address it through a road or railway project is through this fencing and awareness raising and things like that.
Yeah.
So I think this question again from my colleague Suva, and perhaps it's for Ben. She's saying sometimes the IBAT tool and the WDPA data for protected area boundaries, particularly sensitive area, do not match, and in several places. How do we handle such critical scenarios? Should we tally it with our primary data points or local regulatory maps? So this is a very important question, because I know in South Asia, there are a lot of countries where there are a lot of protected areas where we know there's a protected area, but this is not really delineated in Google Maps. And yeah, it's very hard to really figure out where the actual boundary is. So Ben, how should we handle such a situation?
Yes, even the park. I live right outside of a park here, and Google didn't have our boundary right for years, and I kept sending them the accurate data, and they never updated it. That is the value. This question speaks to the value of being able to publish your own data, to be able to contact data providers directly. A lot of that is improving. Foregoing the ability to actually get the data corrected or find corrected data. Typically what Tony and I will do on a project is we will download the best available information. So it sounds like the IBAT tool doesn't maybe have data at the resolution you need that transcends boundaries. So you may need to curate it for your purposes. So you may need to download it. You may even need to edit it, if your reports and your analyses depend on that data. And module 3, Clara will go through using some free and open source tools to do analyses on curated data that she's downloaded and processed on her hard drive to ensure that her work and her analyses are correct and accurate.
Mm-hmm. Right. Thank you, Ben. I remember before I joined as an ADB staff, I used to do some GIS work myself, and I had to do some of those things where we couldn't find the boundary. So then I had to actually go to the site, visit it, and then make like a polygon and create a boundary on my map. But that was about a decade ago. So, again, a question from Nilesh. And I think perhaps Tony, you can take this question. It's a very important one again. It's about when we propose underpasses and overpasses. And because it takes a while to construct these structures, there would be a chance in shifting of the wildlife movement route. So if the wildlife move away, and then what do we do? How do we ensure that the wildlife can again use the underpass or the overpass that was constructed?
The best way is by maintaining protecting the habitat around these structures that are going to go in. So if there's there's typically regulations as far as how far out the heavy equipment and the construction can occur beyond the highway edge. So constructing any sort of infrastructure, whether it's a highway or whether it's crossing structures, it is going to disrupt some animal movement and some animal occurrence in the general vicinity. But by protecting the habitat, the core habitat that's around this area as best possible, that would be the best way to ensure that these species are eventually going to come back in this area and use those structures. If they need to cross during construction, they're going to cross. I mean, for whatever reason, we find that you see roadkill during construction as well. But generally, these species aren't going to take off and move, several kilometers away just because there's construction. They're just going to reduce their activity to different areas. So maintaining the habitat and conserving the habitat in these areas is really the most important. Yeah.
Yes. So actually, this is the challenge that we face in our Bangladesh rail project. And we had kind of phase the construction work so that we make sure that there is at least one particular patch or section where there is forest, you know, for the elephants to use while construction is going on elsewhere. And we called it the silent zone. But that was also very challenging to maintain because in order to even start any kind of basic construction, at some point you have to open up all the forest. There's no way to just keep one patch of forest waiting. So that is the challenge, and that is our concern right now. While we are working on constructing the overpass and underpass in Bangladesh, we are worried that the elephants will, you know, move away. But so far from our monitoring work, they are still using the earlier route. So hopefully we can finish the construction on time and the elephants will still use the structure.
Yeah, and an important part of that too is having, you know, what we call environmental surveillance officers on the project. You know, because there are certain designs, I mean, there's certain instructions in the design plans about how, you know, how much how much habitat can be disturbed. And if you don't have anybody there who's doing the surveillance, you know, the people who are doing the construction can go way beyond those boundaries, and they can, you know, they can destroy habitat, much more habitat than they should. So it's important to have these environmental surveillance officers on these projects too, just to make sure that they're meeting the requirements of the design of the construction.
Right. That's very important to make sure that we have adequate monitoring.
And I'm not sure on ADB projects you have environmental surveillance officers. I would imagine you do.
Yes.
You know, with regards to some of the camps and just all of those things. I've seen those in environmental impact assessments as well.
So we are almost running out of time for our Q&A, and there is this question from Thailand, Oratin of Thailand. She's saying in Thailand, the general guideline for EIA process indicates that the scope of field survey should be, in protected area, should be 500 meters from the center line of road alignment. And she's saying whether this 500 meter is enough for data collection and understanding the movement and distribution of species, and for making the map and analyzing the baseline data. So from your experience, how long does the transect line, or basically, I guess, the transect lines and the coverage and the distance from the road, how far off do you need to go to collect the data?
Well, it depends on what the objectives are, and depends on what the focal species are. You know, in the project in Nepal, we have cameras that are about 1.5 kilometers, so 1,500 meters out. But, you know, to do a proper BBA, you would want to be looking even beyond the 500 meters or even the 1,500 meters away from the road. You want to be looking at, you know, what are the important species that are in the area. You want to be able to look at the intact habitat that remains if this is a fragmented habitat. You know, sampling in those areas of intact habitat, and trying to determine, you know, from that species presence and the importance of some of this habitat for across the road for maintaining connectivity for wildlife populations. So it's, I mean, 500 meters, it's, you know, it's a relatively small scale. It sort of depends on, you know, it's hard to come up with a proper evaluation of what she's asking without knowing more about, you know, how large this area is, what's being impacted, what are some of the species in concern. But
right. And actually, I also, this was a big question because, you know, I've been working on transport projects for many years. And the big question is, how far off do I study? And it really depends on the project. And currently, I am supporting a project in Indonesia. And then we have a team from Australia, CISRO, who are doing like a macro level modeling of the ecological impacts. And from their study, they found that the direct impact of the road, such as, you know, the noise and the pollution and the emissions from the vehicles, it can be between 250 to 500 meters. And then it keeps spreading, like, you know, where you open up, where you cut the trees and you open up the forest. So there is this new light which goes into the forest. So there's this new edge effects which come, and there's change in the growth pattern of the plants and the trees. And then it keeps reducing, and they came up with a study where there is this 500 meter, 1 kilometer, and then it goes right up to 5 kilometer on either side. But the 5 kilometer is more got to do with, like, you know, illegal stuff like poaching and illegal cutting of trees and things like that. So there was this interesting finding on the bandwidth of how far off the impacts can go.
That's true. Yeah, they're quite variable depending on the habitat. Yeah.
So before I invite Jamie to give the closing remarks, if I may ask Ben one final question, and I imagine that our audience may also have this question in their mind, is with regard to this, the capacity and the technical expertise with regard to doing this, you know, data collection and creating the dashboard and GIS. For you, I think it must be easy because you're doing it all the time and that's your job. But how easy is it, do you think, for people to learn and pick up? Of course, we're going to discover this in module 2 and 3, but I'm already curious to know how easy it is. And I'm wondering how widely it's becoming, you know, the practice of this is becoming more common, and how many people are picking up on this. Is it easy for, you know, people to pick up on this kind of data collation and analysis?
The data collection and map making, you know, is similar in complexity in most folks I've interacted with to using their email. You know, even Microsoft Word, you know, there's a tremendous amount of functionality there. So what I've found is once we explain the basic concepts of how to search for data, how to manage it, the symbology or scales and zoom extents, I've found it's readily adopted by folks in the whole gamut of our organizational chart, from the head of our national park to technicians working out in the field. I think it is being rapidly adopted as well. I think earlier, and as I was sharing, I said, you know, I've been working in GIS for over 20 years, and most of my career, I was hoping that this technology would evolve to the place it is today. It's easy to use, it's accessible, it's very user-friendly. I find it intuitive. In fact, I often train people, and they're a little ahead of me each time as I'm explaining how to do things. They're figuring out themselves. So I've also compared this to some of the technological leaps that we've experienced in our lifetimes. Things like the adoption of cell phones and smartphones. Even my dad now is using his smartphone for all kinds of things, using the camera and calling me online. And I think web mapping is experiencing a similar technology leap as cell phone use and adoption.
Yes, so it is possible, basically, for people to pick up. Yeah. So thank you, Ben. So on that positive note, can I invite Jamie to close this first module? And so Mr. Jamie Leather, he is the chief of the transport sector group in ADB. He has 30 years of international experience in transport, working with development organizations, governments, private sector, and research institutions. He leads ADB's transport sector operations and oversees the strategic direction of ADB's knowledge technical and financial support to its developing member countries, private sector clients, and partners. He has a master's degree in science in transport planning and engineering from the Institute of Transport Studies in Leeds University. Jamie, can I invite you to please give the closing remarks?
Sure. Thank you very much, Karma. And thank you everybody for attending. Well over 100 participants, which is fantastic. And it also shows how much importance a lot of people, ADB included, are putting into this topic. So that is great. We've heard the wealth of the digital tools and the resources that are available to collect and analyze data to make sure that we do make better informed decisions and the consequences of transport sector investments, but on the linear infrastructure, be that road or rail. I would stress that there is, we just heard sort of a critical point in time where new technologies or new information is available. And I think data is key to this. And it's not just in this, but in many aspects of the work we do. There are tools out there that would allow us to do things that 10, 15, 20 years ago, we just couldn't have done, or it would have been hugely time consuming. That collection of data, that analysis of data and the use of that data to make much better informed decisions, I think is critical in this. I would also stress that transport must be looked at beyond just the infrastructure. Yes, our government clients have come to ADB to support them in that transport infrastructure development, and indeed to plug much of the mobility requirements in the region, we have provided that support. But we are at a point now where we're looking far beyond just the physical infrastructure of road and rail. We're looking at how that infrastructure is used and the transport activities, but we're also looking at the externalities. And this biodiversity discussion is very much looking at what impacts our transport assistance will have on the environment. And with that, I'd like to echo, I think, what Guang Feng said right at the beginning, that transport should not be seen at the cost of nature, but transport for nature. And with that, much of our developing member countries are still requiring significant investments within transport infrastructure, be that new or upgrade of transport infrastructure. And a lot of that is in parts of the countries that may have been overlooked in the past. So we are looking at areas where perhaps this discussion is much more relevant than it would be on the periphery of a large urban area, where we're looking at more into the rural areas, the connectivity, but also regional connectivity and national connectivity, the major infrastructure routes being built across the region or within major parts of the countries. So well, everything we do, we should be doing it, but not to the detriment of the biodiversity we're looking at. And I think this toolkit is a great way to embed the data collection, the analysis, and have discussions with our clients and our counterparts on how we should be looking at those things. And within transport, I said again, the data will allow us to look at things very differently, but we're also assessing what kind of future assistance and support our clients will be looking at from transport, but also what the future might hold for transport. So within our sector framework, and underpinning a lot of that is a foresight study, reimagining the future of transport in Asia and the Pacific. And this work is linked to 3 of those future visioning activities. Number 3 on resilient transport infrastructure systems, vision number 5 on delivering environmentally considerate outcomes. So already we're embedding the transport needs, the transport activities, as well as those transport externalities. And the transport is a means to an end. We need to look at how it's used and what are the externalities of that. And it's not always negative. There are a lot of co-benefits that we can see as well, particularly if we look at it in a holistic way and ensure that we get out of our silos. Too much is said about silos within our various regional departments, looking at the ADB structure or transport, cross-cutting with our thematic friends in environment and other sectors as well. So this is a great opportunity, and it echoes much of what we're looking to do in the transport sector, get away from sort of the pure infrastructure in terms of building in the thematic issues, the social issues, and outreach to many of our client governments and also across the parts of ADB as well. And this aligns with corporate objectives of working together, a new cultural attitude in terms of ensuring that we are providing the best support, the most innovative solutions, and ensuring that we meet international commitments and support our governments in those. And I think tools like we've heard today are exceedingly beneficial in terms of how we can do that work, working with our clients to make sure that our projects really do address all of the externalities and then are designed and implemented and operated in a way that does minimum harm in terms of biodiversity. And I'd like to thank Tony and Ben for their excellent presentations and response to the Q&As, and also to Karma and her team for putting on the event today, one of many. So thank you all very much, and I'll pass it back to you, Karma.
Thank you, Jamie. Yes, so it's very encouraging to hear that even the transport sector is looking to look beyond the infrastructure and not just focus on the infrastructure, and transporting people and goods from point A to point B, but you're also considering all the externalities. So I would also like to thank Jamie and Tony, Ben, and the entire team from ETG and the Transport Sector Group that is here behind the scenes helping with organizing this webinar. And thank you very much to the audience for asking excellent questions. We look forward to seeing you in the next module, which will be next week on Tuesday. And we will again be sharing some exercises and advanced information a couple of days before Tuesday. So I hope most of you can also join the second module and the third module. Thank you very much, everybody, and have a good evening, good day, and good night to Ben and Tony. I think it's late in the night for the two of you. Thank you, everyone. Bye-bye.